क्योंकि ये इस चैनल की सबसे पहली वीडियो है। तो वीडियो शुरू करने से पहले आप सबसे एक छोटी सी रिक्वेस्ट है, अगर आपको ऐसी इजी पढ़ाई वाली वीडियोस पसंद है तो इस वीडियो को लाइक कर दीजिए और चैनल को सब्सक्राइब कर दीजिए। और आपके लिए बेस्ट क्लास नोट्स और क्विक रिवीजन माइंड मैप का लिंक डिस्क्रिप्शन में दिया है, जरूर चेक करना।
When you really think about it, chemistry is like a universal language. It's this incredible cosmic recipe book with its own grammar, its own set of rules that shows how simple things can transform into, well, everything we see. Today, we're going to learn how to read that recipe book and unlock the secrets behind those amazing transformations.
So here's our game plan. We're going to start with the basic language, how chemists actually write down what's happening. Then, we'll get into the one unbreakable rule that governs every single reaction in the universe. After that, I'll show you a super simple recipe for balancing any equation. And finally, we'll explore the main ways elements build, break, and trade places to create the world around us.
All right, first things first. To understand these incredible transformations, we have to learn the lingo. Chemists have a very specific way of telling the story of change, and it all boils down to one simple core idea.
And that idea is the chemical reaction. At its heart, it's just any process that creates something brand new. Think about it. When hydrogen gas and oxygen gas get together, they don't just hang out as a mix. They become a totally new substance, water. And that transformation, right there, is a chemical reaction.
So, just like a chef writes down a recipe for a cake, a chemist writes down a chemical equation. It's basically just shorthand. It's the recipe for the change. So instead of writing out a whole sentence like hydrogen and oxygen combine to make water, we just use symbols. H₂ plus O₂ gives you H₂O. Same story, just told in the language of chemistry.
Now, every single one of these recipes has two parts. On the left side of the arrow, you have your ingredients, right? The stuff you're starting with. We call those the reactants. And on the right side, you've got your final dish, the new stuff you just made. We call those the products. Simple as that. Ingredients on the left, final dish on the right.
Okay, but here's where the kitchen analogy kind of breaks down a little. See, in the kitchen, you can eyeball it, you can add a pinch of this or that, but in chemistry, no way. The amounts have to be perfect. There's this unbreakable rule that says every single equation has to be perfectly, and I mean perfectly, balanced.
Which of course brings up a really important question. Why? Why do we have this obsession with making sure the left side and the right side match up perfectly? Well, the answer is tied to one of the most basic, fundamental laws of our entire universe.
It's called the law of conservation of mass. And what it says is just profoundly simple. You can't create matter out of nothing, and you can't make it just vanish into thin air. Every single atom you start with has to be there at the end. All you're doing in a chemical reaction is just rearranging the pieces.
So when you think about it, balancing an equation is really just a form of cosmic bookkeeping. We're just auditors, checking the books, making sure that every atom of hydrogen or oxygen that went in is accounted for on the way out. Nothing gets lost. It all has to add up.
Okay, so we get why we have to balance equations. It's the law. But what about the how? How do we actually do it without just guessing over and over? Well, lucky for us, there's a simple, step-by-step recipe that works for almost any equation you'll see.
It's all about following a specific pecking order. You always start with the metals, things like iron or copper. Once they're balanced, you move on to the nonmetals. After that, you tackle the oxygen atoms, and you always save hydrogen for the very end. And hey, if changing one thing messes up something you already balanced, don't sweat it. That's what step 5 is for. Just go back to the top and run through the list again.
Awesome. Now that we have the language and the rules of the road down, let's get into the fun stuff, the main types of reactions. We're going to start with two that are basically perfect opposites. One is all about building things up, and the other, it's all about breaking them down.
On one hand, you've got combination reactions. This is where two or more simple ingredients join up to form one single, more complex thing. A plus B gives you C. On the other hand, you have the total opposite, decomposition. That's where one complex thing breaks apart into its simpler pieces. C breaks down into A and B. One builds up, the other breaks down. Two sides of the same coin.
Want to see a cool combination reaction? Just burn a strip of magnesium. It grabs oxygen right out of the air and combines with it in this flash of blindingly white light. And what are you left with? A single new product, a fine white powder called magnesium oxide. This reaction also pumps out a ton of heat, so we call it an exothermic reaction.
Now, for decomposition, you usually have to put energy in to break something apart. A great example is heating up these green ferrous sulfate crystals. As you heat them, you can watch them change. First, they turn white, and then as you keep heating, they turn into a reddish-brown powder. The original compound is broken down into 3 totally different things, including 2 gases that smell just like a burnt match. Since it absorbs heat, we call this an endothermic reaction.
So, we've seen elements build things up and break them down. But one of the most interesting things they do is swap places with each other. And this isn't just random. Oh no, it's a full-on competition, and it's all based on a clear pecking order of who's toughest.
This is called a displacement reaction. The best way to think about it is like a competition. If a more reactive or, let's say, stronger element shows up, it can literally kick a weaker, less reactive element out of its spot in a compound and take its place.
So, how do we know who's stronger? Well, we use this handy little cheat sheet, the reactivity series. It ranks the elements from the most reactive at the top down to the least reactive at the bottom. The rule is simple. An element can only kick out another element that's below it on this list.
Let's make this real. Imagine you drop a regular iron nail into a bright blue solution of copper sulfate. If you look at our list, iron is higher up than copper. That means it's more reactive. So the iron kicks the copper out of the solution. And you can actually see this happen. The blue solution starts to fade to a pale green, and that poured displaced copper, it forms a reddish-brown coating all over the iron nail. So cool.
But what happens when 2 compounds react? Well, then you can get what's called a double displacement. This isn't one element kicking another one out. It's more like both compounds just agree to swap partners, forming 2 completely new compounds in the process. This one is like a magic trick. You take 2 totally clear, colorless liquids, sodium sulfate and barium chloride, and you mix them together. The instant they touch, the ions swap partners. But here's the kicker. One of the new partnerships they form, barium sulfate, is a solid that won't dissolve in water. So out of nowhere, a cloudy white solid appears and starts to settle at the bottom. We call that solid a precipitate.
So you see, whether elements are combining into something new, breaking apart, or just swapping partners, it might seem chaotic at first glance. But it's not. It all follows this beautiful, elegant, and predictable set of rules that are woven into the very fabric of our universe.
And get this, these exact same rules that we see in a simple lab experiment, they're at work right now in the fiery core of a distant star and inside every single cell in your body. It really makes you wonder, doesn't it? What other amazing universal rules are out there, hiding in plain sight, just waiting for us to discover them?